So this is the very first section of chapter 1. Right here it reads, a variable is a letter that is used to represent one or more numbers. Okay? The numbers are the values of the variable. Okay, so let's say x is a variable. And once you know that x is equal to 3, the 3 is the value of that variable. A variable expression, an expression is a collection of numbers, variables, and math operations. A variable expression is also known as an algebraic expression. Okay, so before we even move on, let's just talk. When you express yourself, what does that mean? If you're expressing yourself to somebody else,
you share your feelings.
You're sharing your feelings. You're stating so. You're saying something, right? Okay. So a math expression. Let's not even look at this right now. But a math expression is something like 3 plus 2. It says something. It tells you to do something. So when you express yourself, when you have a math expression, it's telling you something. It's telling you to add 2 to 3. 3 plus 2, right? And you get 5. A variable, we said, is a letter. Okay, so most of the time we use the variable x, the letter x, that represents a number. So that's a variable. When you say variable expression as opposed to a math expression, right, or just a regular expression, a variable expression has a variable in it, and it has math operations and numbers. Okay, so an algebraic expression or a variable expression, because those are the same things. It has a math operation, has some math operations, has a variable, has some numbers, right? Here's another variable expression. What does that say? It says 3x, but what does it really tell you to do? It tells you to multiply 3 times x, right? And as we're going to learn in this section, when there's no, it's not just learning one word. Like when there's no number between the 3 and the x, you're multiplying. So yeah, 3 times x, but there's many words that could express the same thing. So instead of 3 times x, you could use the word product, like the product of 3 and x. Product means multiplication. Or right here, when I say x plus 2, instead of x plus 2, I could reread this with different words, saying that like the value of x increased by 2, right? Or I could say, instead of x plus 2, I could say the sum of x and 2. So there's many different words that mean the same thing, and that's what we're doing today on this section. We're talking about words in algebra, okay? So right now I want you guys to take a couple of seconds and just write down in your own words. It doesn't have to be exact. What's a variable? So somebody just said a letter that represents a number. You could write that down. You could just write down a letter. Most of the time, what's the variable that we use in algebra? Most of the time? X. Right, so that's a good example of a variable. It's not the only one. We sometimes use Y, A, B, C. We could use any letter we want from the alphabet. Those are all variables. How about operations? What's an operation? Well, that's when a doctor gets a knife and cuts you open. No, I'm just kidding. An operation is what in math? Multiplication, division, addition, subtraction, square root, sure, exponent, right? So we have all these different operations in math. So let's just write some of those down right here. What did we say? We said multiplication. So parentheses, exponents, multiplication, division, addition, subtraction. Those are all math operations. And that's actually the particular order we're going to be learning the correct order of operations tomorrow, not today. Right now we're just talking about what are operations: multiplication, addition, subtraction, division, all these different operations. An algebraic expression. Okay, so what's an expression? It tells you something. So when we're talking about an expression in algebra, we're talking about a collection of what? It says it above. So it's a collection of numbers, variables, and math operations. So just to give an example here, we said like 2x plus 3, right? That is a variable expression or an algebraic expression. It tells you something. It says 2 times x and then plus 3, right? Okay. Anyway, what does it mean to simplify? To reduce a fraction, okay, to make it nicer, to make it more simple, to do any math possible. Let's write that down. So to do any math possible. So once again, if I have 3 plus 5, that is definitely not simplified, right? I could tell you to simplify this and you would say 8, right? 8 is a simplified expression right there, or the answer to 3 plus 5. How do you evaluate a variable expression? So this is something from tomorrow's section, but I'm throwing it at you right now. Whenever you read these words, evaluate the variable expression, I want you to think of the words plug it in, right? Now, what do I mean by plug it in? They're going to give you a variable expression, kind of like 2x plus 3, and then they're going to tell you x equals 5. So they want you to evaluate the variable expression, you plug in the 5. Maybe I should write an example of that. Actually, if we just look down at the bottom of this page, again, it says that this is from section 1.2, evaluating. But right here, to evaluate a variable expression for a given value means plug it in, then simplify. So in class, we're going to eventually do this. We're going to say evaluate the following variable expressions when y equals 6. So like on number 1, it says 5y, but that's an algebraic expression that tells you to do something. It says 5 times y, and above on the instructions it says that y is what? On the instructions, what does it say? Y is what?
6.
Y is 6. So when you plug it in, you have 5 times 6. Why did I write that again? I don't know, but the answer is 30. That's what we call evaluating a variable expression. Okay, so before we do the rest of these, let's jump back up to the words in algebra. So up here, we have a table, and as you can see, we have a variable expression right here on this column. Right here in the middle, we have the meaning, and right here, underline implies a switch in order. Okay, we'll get to those in a little while. And over here, the final column is the actual operation that you're doing. So like I said, there's many different words to use when you want to represent the operation multiplication. There's many different words for division. There's many different words for addition. So let's look at the very first one, multiplication. So they could write it like this, 3x, or they could write 3 parentheses x. Both of these mean 3 times x. When there's no symbol between it, you're multiplying. Right here, 3 times x as well. And that's what it says on the meaning right here, 3 times x. Now, we said another word for multiplication is the word product. So we need to learn that. We need to memorize that. The word product means multiply. Okay? Let's move on to division. Now, remember, division could come at you as a fraction because that fraction bar is really a division bar. This is saying 16 divided by b, or it could also mean 16 divided by b with the actual division sign. Okay, so either one of those is good. Not only that, sometimes we don't use the word divide. Sometimes we use the word quotient. If we look over here, it says 16 divided by b. We could also use the word quotient. The quotient of 16 and b, that's also the same thing as 16 divided by b. This one's really interesting. Adding and subtracting is really interesting because we could throw out many different words and some of them are kind of tricky. Okay, so what does it say? It says 4 plus s. 4 plus a number s. We don't even know what that number s is, but here we go. How could it be written? It could be written as 4 plus s. Or maybe the sum, the word sum also means add, of 4 and s. 4 increased by, that also means add. Now, these next ones are very interesting because they are underlined for us. More than, added to, greater than. Now, up here, it says if they're underlined, it implies a switch in order. Okay? So, s more than 4. Okay? A lot of people read that s more than 4 and they write it like this, s plus 4. And ladies and gentlemen, that's incorrect. Right? Even though it would still work out if you were evaluating a variable expression, but the words more than imply a switch. You need to think of something like in the real world. What if I said, what's 1 more than your age? What's 1 more than your age? You're not going to put 1 plus your age. In your head, you're going to put your age plus 1. Does that make sense? Same thing with less than, right? If I say, what's 1 less than your age? You're not going to say 1 take away your age. You're going to put your age first and then minus 1, right? So anything that's underlined implies a switch here. So s more than 4 really means 4 take away s. Okay? S added to, s more than 4 is really 4 plus s. I said take away, I'm sorry. S added to 4, again, it's underlined, it implies a switch. 4 plus s is the correct expression. Okay? Again, if I were to say, what is 2 added to your age? You're not going to say 2 plus your age. You're going to say your age plus 2. Over here, s greater than 4. Again, the greater than underline implies a switch. You're going to have 4 plus s. So those are the tricky ones right there. And same thing with the subtraction. Like this guy over here, it says 9 minus x. Yeah, you could write it as 9 minus x. But it could also read x subtracted from 9. And the word subtracted from implies a switch. So it's not x take away 9. It's actually 9 take away x. So it implies a switch. Subtracted from. Okay? 9 decreased by x. There is no switch there. Again, on all these, if you think about like your age, it'll make more sense. If I say, what's your age decreased by 1? Are you going to switch it? If I say your age decreased by 1? No, you're going to put your age and then minus 1. So there is no switch there. Okay? But if it says, what's 1 less than your age? Then, yeah, you switch. You put your age first and then 1. Okay? So anything that's underlined implies a switch. Down here, we have some examples. So I want you guys to go through these. I'll give you guys a couple of minutes, and then I'm going to hit pause, and I'll post the answers right now in this video. So number 1, the sum. What does sum mean? Does it mean divide? Add, right? So you're going to put the sum, there's sum, of what and what? 5 and x. So you are not going to switch it. 5 and x. Above on your notes, it's not underlined. So this is it. 5 plus x is your algebraic expression for that sentence right there. So move on, number 2. What does quotient mean? Divide. So you could write it like this, 6 divided by x, because quotient means divide. Or you could put 6 divided by x. Either one of these is perfectly fine. Moving on to number 3. 5 more than x. X plus 5. Again, if it said 5 more than your age, you're not going to say 5 plus your age. You're going to put your age first and then add 5 to it. So we're going to put x plus 5. It did imply a switch because it was underlined. Let's move on to number 4. The product of 2 and x. How do I write this? 2x. Just 2x, right? 2x, because when there's no operation between it, you automatically assume it's multiplication. And that's what product means. It's multiply. Okay? So 2x is a correct algebraic expression there. Okay, now 2 subtracted from x. That's right, there's a switch, right? Above on your notes, subtracted from implies a switch in order. So we know we're subtracting, but this x is going to go over here, and this 2 is going to go over here. Once again, there's a switch in order. So x right here, 2 right there. X minus 2 is a correct algebraic expression. Number 6, 1 more than twice x. All right, there you go, 2x plus 1. The more than implies a switch, right? And we know we're adding. And what are we switching? This twice x is going to go over here, which is 2x. And this 1 is going to go over here, which is 1. So we really have 2x plus 1 is a correct algebraic expression. Good, you guys got that. Number 7, 3 more than a number. You could say x plus 3. That's good. Or, yeah, that's it. Number 8, let's move on. The sum of 12 and twice a number. Okay, so it's getting a little bit long. What are we doing? We are summing, which means we are adding. Do we need to switch anything? No. And what are we adding? We're adding this and this. So you're going to put 12 plus twice a number. Now later on, we're going to place the variable expression in a certain order with the x term first and the constant last. But right now, this is good enough, especially because the word sum does not imply a switch. So, okay, remember, evaluate the following variable expression. Y equals 6. All we need to do is plug in 6 for y. So right here we really have 24 divided by what? 24 divided by 6. What's the answer? 4. Number 3. Instead of y plus 19, what do we have? 6 plus 19. And what's the answer? 25. over here, instead of negative y minus 2, what do we have? Negative 6 minus 2. Negative 8. There you go. And number 5, instead of y divided by 3, what do we have? 6 divided by 3. So the answer is 2. And over here we have 27 take away y. Instead of y, what do we have? 27 take away 6. Answer is 21. Too easy. 7, negative 2 times y. Instead of negative 2 times y, what do we have? Negative 2 times 6. Now, notice I'm putting them in parentheses because if I just put negative 2 and 6 and I sneeze and I look at it, it looks like negative 26, right? Again, I put parentheses just to remind me that I'm multiplying. The answer is negative 12. And last one, 3.2 plus y, but instead of 3.2 plus y, we have 3.2 plus 6, which is 9.2. You could, actually it's a good idea to plug in your values with parentheses all the time, but I'm going to end it right there. This video is already kind of long. So on the back side, let's turn to the back side of this worksheet. We have our homework, and this is one of the few times that we're actually going to be working from the book. So right here, I would like you to write down the operations and the verbal phrases that are in the diagram in your notebook, in your actual book on page 6. You guys don't have the book at home. We have the book right here in class. So here's the page. Oh no, that's a homework page. I'm sorry. Okay, so here's a picture of page 6 in our books that we're doing in class. And of course, you're just going to copy this table right here into this area. I know it's kind of silly because it's already written for you on the other side, but you learn it better when you actually write it down yourself. Now, one thing I would like you to do on page 6, not on the book itself, but on your notes when you're copying it, yeah, you're going to write down addition on the operation column. And over here, you're going to put more than, sum, plus, increase by, and added to. But let's underline the ones that imply a switch. So, does more than imply a switch? Yes, it does. Does sum imply a switch? No. How about plus? No. How about increased by? No. Increased by, no. Like if I say, what's your age increased by 1? You just put your age plus 1, right? You don't put 1 plus your age. How about added to? 3 added to 7. Or 3 added to your age. Yeah, you switch it. So let's underline those two. Of course, on the other side, we have different ones like greater than. Let's move on. Subtraction. Which ones imply a switch? Less than? Does that imply a switch? What's 1 less than your age? Are you going to put 1 minus your age? That'll give you a negative number. No, right? So 1 less than your age, you have to switch right there. So right there, less than, there's a switch. How about subtracted from? What's 1 subtracted from your age? Yes, that's a switch also. How about the difference? What's the difference between your age and his age? You just subtract them, right? So difference, no switch. How about decrease by? 3 decreased by 1. No, you just write it, 3 minus 1. And minus, you don't switch either. And that's about it, guys. Copy that down. That's this first part of the homework. Now the second part is page 7 in your workbook, in your math book. And of course, right here, we're doing the odd ones. So you want to write a verbal expression. It might be different than your partner. You might put 2 times m, which is totally fine. Or you might put the product of 2 and m. That's totally fine. So you guys could have different answers, but they're still correct. We're doing the odd ones only. Okay. So number 3 right here, I would put. Okay, number 3 is a little ridiculous. Let's skip number 3. Let's start with number 5. Okay. We're doing the odd ones. So 6 less a number t. Now it doesn't say less than. That's a really tricky one. Unless it says less than, that's when you switch. Right here, 6 less a number t. Right there you would say 6 minus t, which is ridiculous because less than would imply a switch. So 6 less than a number t. You know what? That's a horrible one too. I'm not going to give you that one on a quiz. Let's just scratch that one out. Let's start with number 7. How's that? So let's do 7 through 27 odd as our homework. And on Edmodo, you will have answers there so you could check. Number 7, 1 minus the quotient of r and 7. So 1 minus, that doesn't imply a switch. So that would be 1 minus. Quotient is division. You could write it as a fraction. So you could say r divided by 7. So you could say 1 minus r over 7 or 1 minus r divided by 7. Both of those are good. Check Edmodo for your answers. You have the rest of the class to work on this. On Edmodo, the answers are there. And at my desk, I'll have a teacher edition so you can check your answers. 1 through 27 odd.